Ciao, Luca.
Ciao.
It's good to see you.
Parker.
It's been a pleasure being out here in Florence and getting to see the facilities firsthand, seeing how the SmartXide TRIO gets made from the ground up, everything from the little bolts to the assembly to the testing, and it's been really incredible for me to see and to really appreciate all the work that has gone into the device. And I understand you were very pivotal in this device. So to start out, could you maybe describe your involvement in creating the SmartXide TRIO and maybe some of the problems that you saw that were out there or gaps in technology that the SmartXide TRIO aimed to bridge?
Yeah, first of all, I'm pleased to have you here and to meet you personally. We had several calls before, but I mean, to speak face to face is different. I'm involved in this kind of clinical and technical development of the CO2 laser for now more than 20 years. So let's say I was born with the CO2 laser, and I've studied and learned by competitors, by surgeons that I was meeting in the beginning, and I understood that there was something to do to improve the quality of laser surgery, and particularly the CO2 laser microsurgery, mostly in the beginning in the ENT field for vocal folds, but also in the middle ear and other. What I understood really in the beginning, the first years, was that the real game changer was the scanner. The important stuff to me was to learn the more that I can to understand how we could improve the beam, the movement of the beam, the ergonomic of for example, of the joystick, and also something that we are still working on. It's how to focus the CO2 laser, because the CO2 laser, with difference of other kind of lasers that work in fiber, the CO2 laser can work in the hollow fiber, okay, but the most fascinating, let's say, opportunity is to focus it in different distances, so you have optical zooms, very refined, and also to move this focused beam on the tissue in a way that was perfect for surgery, and for that kind of surgery was the challenge that in the beginning we had. So working on it, we started doing trials. We started staying in the lab for days, trying and shooting on tongue depressors, on pieces of meat, on everything. And then I was coming back and I was telling to the others, look, I've seen this. Sometimes I was working in that period, and still now I work with a guy that, in my opinion, is actually a genius. It's called Angelo Bove. He's an engineer that works in the company, and we were like in this creative, fantastic mood in which sometimes also, I don't know, before going to bed we were calling each other. I said, I have this idea, and he was calling me, something like that. Then when we had the first hybrid micromanipulator, EasySpot hybrid micromanipulator with the hybrid technology, with the high-scan surgical on it, and we were trying it, so I thought that this was, I mean, we were arrived somewhere in which we could really do something important. So we were studying, I mean, I thought of this idea to having a different remote control on the joystick comparing to the competitors that had more functions, that could be more ergonomics and everything.
Could you talk about why it is so important to focus the laser? Yeah,
it's very important to focus the laser, because when you go on the tissue, the energy density that you have to go in the tissue has to be the more that you can. So if you focus the laser, for example, in a quarter of a millimeter or spot that is typically the spot that we produce with the micromanipulator, then you have an energy density so high that the tissue literally explodes when you go in pulse mode, and you hear the sounds, and you have no thermal damage because the heating can't spread. So for conduction in the surrounding parts. So the important stuff is to have an energy density that is the higher that you can. So while focusing a laser, it's to use the laser in the better way that you can. So to focus perfectly on the tissue, it means that you have a perfect results on the tissue. And if you have a perfect focus beam on the target, then you can move it with a scanner and using the velocity of the scanner to create thermal damage that is different. So this is the game that we have now, and regulating the velocity of the scanner and the power in that sense, you have even not to take care about defocusing like it was before. Before they had just one spot, and so they had to focus or defocus the laser to change the energy density and to destroy more bigger areas, for example, to vaporize. Nowadays it's not like this because you have a scanner. So if you want, you work always in the better way, that is so with the maximum energy density. Then you regulate the energy that you want on the tissue, regulating the scanner and regulating the power of the laser. That is much easier.
Yeah. We've established that the TRIO is able to provide the surgeon with a high degree of focus, that they're able to have a lot of options in the laser tissue interaction, cutting and coagulation. With the scanner micromanipulator, they're able to produce more than just a single dot. Now, those three combined, what does that mean for a surgeon when he's doing procedures?
Okay, first of all, if you go, for example, I mean, because you have several kind of things that you can do. If you want to cut precisely, for example, in a vocal fold, you want two things. You want to take away the pathology, and you want also that the patient then speaks correctly. I mean, with no. So the less thermal damage that you produce, and the better is. Accordingly to the fact that you have to coagulate enough to have a bloodless field. Then you have also, you have to be able to do other things. I mean, you can just do, I don't know, a final brush, easy brush with other figures like the hexagon, for example, either to destroy some lesions like for papillomatosis or something like that. So there are different options, and this is just on the vocal folds. Then scanning micromanipulator, you can use it either also in other specialties. I mean, you can use also in ENT in the middle ear to do the one-shot stapedotomy. You can use it in gynecology colposcopy. You can use it in proctology nowadays. I mean, in neurosurgery, especially in neurosurgery, you had great stuff, because in neurosurgery, for example, I mean, I'm speaking, in neurosurgery, if you have to destroy, for example, a benign lesion that is in the middle of the brain, you have like meningioma, for example. And meningioma is like Mandarin, let's say. Okay, so the lesion is all here. You have to destroy the lesion, and then you have to take away to peel away the membrane, so that it doesn't come on again when you have cured it. But the point is that while you are on the meningioma, you have to be fast, because the intervention are even, I don't know, 13, 16 hours of intervention. So the more that you are fast in destroying the lesion, that can be also quite big, and the better is. So you need some figure with a scanner that are fast. But then when you arrive close to the brain, you have to be delicate. So the CO2 laser is fascinating because it can be with the scanning. With the scanning you have one line that is perfect to cut a vocal fold, delicately and precisely, and with a high reproducibility. Then you have some figure that can ablate, like fast ablation, we call it fast ablation, very fastly the lesions. And then you have some figure like the hexagon, for example, that are so delicate with the right parameters that you can just peel the tissue doing like I don't know, less than 10 microns of damage. I always thought that I would want to leave a sign in giving something to the surgeon that was better for them, for their skill, for their work, but also better for patient, because each time I say under that laser, it could be me, it could be my mother. So this is important.
You had talked about how you wanted to leave a mark with it, and leave something that would help patients and doctors, and maybe you could elaborate a little bit more on the advancements that have come from this device, how that could help a doctor's practice.
That we are most, let's say, focused, because it's like this. It's how to let the doctor, the surgeons, be more confident in focusing the laser, to have the energy density, the right energy density to operate, and also to work on the ergonomics. So, for example, the fact of having the joystick like it is now.
Yeah, so actually I'm glad you brought up ergonomics, because it's something that gets forgotten about a lot in surgeries. Obviously we want the focus to be on the patient, but like you described, some of these procedures can take several hours, and there's a patient on the table, but there's still a person on the other end. So could you maybe just touch on a little bit how important ergonomics are in the design of medical devices?
Ergonomics is everything, and not only ergonomics. The usability is incredible. I mean, it's very important. The point is that when I see something that is, I see, for example, I go in the operating room and I see something that is not working okay for the surgeon because he's not comfortable with the position, or either, for example, also in the interface, on the software interface of the system, has to be something. Well, my professor in surgery, when I was in the university, was telling me in the OR, the seconds become minutes, and the minutes become hours, and these hours, I mean, okay, maybe it's not precisely like this, but the concept is this. Each minute that you save for the surgeon to do stuff, it's minutes that the patient stays less in total anesthesia, for example. So it's, and if you think to something, for example, in neurosurgery, that the intervention lasts like that, to make that an intervention last 14 hours instead of 16 hours is 2 hours less of anesthesia. Sometimes you have to stop the intervention because you can't go over with the total anesthesia. So everything is important. Also the interface, the usability. When you have the interface, you have to see the keys in which to play, to press. I mean, to be, and all for example, the competitors has just one function on the joystick. They can just rotate the line. That is a figure. We have 3 functions. We have the rotation. We have the dimension of the every scanning figure. We have also the possibility of going scan on, scan off, because sometimes you need also to have just a point, for example, in the laryngoscope, to cut precisely to the in the in the layer, in the border of the laryngoscope, for example, or or you want either to cut with a no scanning and everything. Also the centering, you can do it from the joystick. The more that the surgeon can do from the joystick, instead of asking to the nurse to do it for him on the system, and the more is the time that he save for him and for the patient.
With that value of constantly wanting to improve things and all the effort that went into this, originally with very specific features, like you talked about the joystick of being able to control the shape and the size of the shape, what do you think have been some like key foundational ways of approaching not only the Trio but really all the devices that DEKA produces? What's been important for you and your team as you guys are thinking about what the next device is, what the next improvement's going to be?
First of all, we think where we are, and then we think where we want to go. When we want to go, where we are now, we have good CO2 laser. We are improving the CO2 laser, but the thing that we want to improve now, it's to improve even more the accessories. So we are working mainly on the accessories. We are working on the ergonomics. We are working to make them more compact. We are thinking to something also, for example, the joystick. The joystick, there is one other thing, I think that is like this, is that the more that you are enjoying in doing something, and the better it is. So, for example, our joystick, it's a joystick that it seems like a bit to stay on a video game, So first time that I was going, the first times that I was taking the joystick to surgeons in some demos or something in the beginning, years and years ago, they were enjoying. Yeah, they were saying, I want to do more. It's finished the intervention.
Yeah,
they were
probably
enjoying.
a younger demographic of surgeons now. A lot of guys that
even
grew up
more
with video games, so they
even
probably
more. Yeah,
really get that.
Yeah, probably. Okay, this can be a gap, let's say. Surgeons also, and this I can understand this. They said, I know how to do one thing in a way, so I'm scared to do something in another way. What I always say is, and I was telling the story today to you about this friend of mine, Dr. Dallari, but also other guys that in the beginning tells you, no, I don't need a scanner. The scanner is a gadget. The scanner is not a gadget. The scanner is something that gives you the ability, and now I will tell you something that is extremely important. Gives to a guy that has never used the laser, that can use it. And to a guy that is a superhero of the laser, to use it better. So if you go, and it's another thing that I wanna really to stress, and this is something that is extremely important to understand also for the surgeons. The first thing that the surgeon asks you when you arrive there and to let him try the system is how deep it goes. This is, I want to say, how deep it goes. It's a beam that is focused on the tissue. If you stay steady and you don't move it, it goes deeply how much as it can, no? So I can't say you how deep it goes because it's in your hand. If you have a dot, just a dot that you move it manually. With a scanner, I can tell you how deep it goes because the scanner, I put a line and I said, okay, do a scanning and then you stop it. So when you do a line, I give the right energy, I give the way of emitting of the laser for the effect on tissue that I want. But then after that energy given on the tissue, it stops. So I can tell you this goes 0.5 millimeters deep. Without the scanner, this is impossible.
It's a really simple but profound thing that this device controls is the thermal damage. And could you maybe talk in a little more detail on like what the importance is of controlling that thermal damage and how that relates to the patient and the surgeon?
One example, if we are talking in ENT surgery, okay, you have a vocal fold, you have a benign lesion, okay, benign lesion is called phonosurgery, okay, phonosurgery. The important stuff is to take away the lesion, but it's not a cancer. So the important stuff, when you take away the lesion, is the patient has to talk like he was talking before. Maybe there are singers that do this kind of surgery, so you have to be extremely delicate, okay? So you don't want to produce thermal damage. Even if it bleeds a bit, it's okay, because it's a little lesion and you have to be precise, and that's it. If you take away a cancer of 1 or 2 centimeters, you take away, sometimes you do like cordectomy of type 4 extended, you just take away everything. So in that case, you need to be coagulative also, because you are taking away a tumor that is bleeding. So you have to take away the pathology, because he will die about this. Then obviously it's better if it is a little tumor, if he can also speak perfectly, but it's a compromise, you know. So you can regulate with the scanning options, you can regulate the how much thermal damage you want to produce.
Yeah, and you talked about before how this is a great device in the hands of a beginner, but also in the hands of an expert. And could you maybe talk, obviously it seems like there's some very clear advantages for the beginner associated with the scanner micro manipulator, like you just said, giving them more confidence. Could you talk about how this is also a great device in the hands of an expert?
The scanning technology make the great surgeon able to go further, you know. If once you were stopping just, I know, doing tumors or one early stage and also not very extended, now with the scanning technology you can do really virtually a laryngectomy. I mean, you can really take away also big tumors. I've seen doing it. Without the scanner, I mean, I had great surgeons that were telling me really now. In the beginning when we met, he said that the scanner was a gadget, and then he said to me, you know, I've done something, an experienced guy. I've done something with a scanner that would have been impossible to be done.
Yeah. What do you think made the difference for them to see it not as a gadget anymore, but as an actual tool?
When they use it, then they understand that they can't do without it, because it expands the solution that they had. For example, even if you want to cut not on a straight line on a vocal fold, because the lesion is not straight, you can use just a little line. Rotating the line, you can create the shape of but also matter of energy density. It's very different to cut with a steady point that has not the control of the scanner, or just with a little line that goes like this, because the energy density that you have, it's controlled by the scanner. So it makes you able to do something that you couldn't do in another way. We need to have something that get to the level of surgery, and this is what hybrid and high-scan surgical and SmartXide2 family trio, with all the opportunity that it has, is to level up the level of surgery. Even more complicated cancers, we can put the level higher also in neurosurgery, that is very delicate. We can use something that will improve the life of surgeons and life of patients. So, I mean, we have already done, but we want to do even more.
And what do you think that means for surgery broadly by using new technologies such as the scanner micromanipulator to do, like you had said, to be able to level up surgeons where even the less experienced surgeons are now maybe on a level that very experienced surgeons used to be a few years ago. Now the very experienced surgeons are at an even higher level. What implications does that have for not only surgery specifically, but just for healthcare in general?
Before that the laryngoscopy was out. If you have a cancer, you had a cancer in larynx, you had to cut the larynx. I remember I had some relatives years and years ago, you know, with the tracheal tube here, because it was like this. They took away the larynx and that's it. And now with the laryngoscopy, microlaryngoscopy, and then in the beginning you had just cold blade, so it was bleeding and everything. Then they were doing maybe with electrosurgery, I mean, and so thermal damage. Now you are doing this with lasers. So with laser you can expand the effect. This what means that you have less cost, because a guy, for example, that entered to do a normal intervention on the vocal folds, it goes off. I mean, we do it in day surgery normally. I mean, if they do a big intervention on cancer, maybe he stays there for 1 day or a couple of days, but not more. So you have less hospitalization, you have less morbidity then. I mean, you have people then who have not dysphagia, less cost for society in general.
Talk about some of the optionality that the TRIO provides for surgeons.
One important stuff, why it's called TRIO. It's called TRIO because it has the CO2, both delivered scanning CO2 laser, and then the CO2 fiber, hollow fiber, and also a diode laser, 980, 9 nanometers diode laser. That is more coagulative. So you have a fiber option, because we know that the CO2 is not coagulating so much. I mean, it's coagulating what you need, but it's not its ability to do a lot of thermal damage and more thermal damage. Being absorbed more by hemoglobin, to have a second wavelength that is also coagulative is important for some lesions, for example, when you need the flexibility of the fiber, but also more coagulative power. For example, you can use it, I mean, for nasal procedure, turbinates, for, I don't know, glossectomy, something in which it bleeds, or even supraglottic lesions that are bleeding more. And also very important is that the TRIO, it's the only, for the middle ear, you can do it, the stapedotomy intervention in the middle ear, you can do it one-shot stapedotomy, and that is the most evolved technique. You can do it both with the CO2 laser, with the spiral figure, and also with the diode laser. And with the diode laser, as we were talking about the fact of being user-friendly, we thought it was really not very smart to do like it's done nowadays, to do the rosette technique. So you do multiple hole and then you refine with the drill. So I think it's quite pointless to use a laser than when you have to use a drill, with all the problem of using a drill. So with the diode it's quite easy, because you get a fiber and you put it on a stape, and the fiber has some diameters that are different according to the prosthesis. So you put the fiber, and with the fiber you just touch the stape, and with the right parameters that we studied for a long time, we have the perfect energy to do the hole, and the laser radiation is absorbed just by the piece of bone that is ablated, and you don't produce thermal damage, because the thermal damage is a question of time. Why the scanner is fantastic? The scanner is fantastic because you can deal with the time of exposure. the less that you expose it, and the less thermal damage you do. So the same principle is with the one-shot stapedotomy with the diode. You give a high energy, and they are scared about giving a high energy, but the problem is not to giving the high energy, it's the time in which you give it. So if you give it in a short time, it's enough to produce the hole and not doing thermal damage. We have literature. I mean, it's a procedure that, in my opinion, will change the kind of intervention in the middle ear, the stapedotomy. I mean, one-shot stapedotomy, it's the real, in this sense, is a game changing of this kind of surgery. And in future, I think that will be a standard more than it is now.
Could you compare and contrast the differences between the Rosetta technique versus the one-shot stapedotomy?
For sure, for example, is also the time, because with the Rosetta technique, before you have to. We have got some footage, from the internet, and we compare the intervention. I mean, the time that it takes to do the hole in the stape. I mean, before you have to do the Rosetta, you have to do multiple holes, and then you use the drill. So when you do the first hole, and then you have to do more. With the one-shot stapedotomy diode laser, the first time that setting the right parameters with the first hole, it's done. You put the prosthesis and it's done. So the fastness is the most important stuff. And then also it's a question of being user-friendly. I mean, you don't have to go there and, to do multiple hole, close and everything. You just touch, shot and done. So it's more easy. So this is the direction in which we want to go, to make the life easier for surgeons.
Now, some surgeons may be nervous about using a micromanipulator for a one-shot stapedotomy because of the exposed nerve. What would you say to them to maybe ease some of that concern?
The precision of a micromanipulator is very high on the scanning, so sincerely, you can save. You have no problem with the facial nerve. Also, the CO2 laser. The radiation of the CO2 laser is entirely absorbed by water. It's so, and also the reflection is really poor, so you have no problem. And if you are scared, you can anyway use with the TRIO. You can anyways use the diode laser that you have in. So the thing that, for example, in stapedotomy, if you have a floating foot plate, that can happen. Especially with the drill, you can move the foot plate. So you can do it also with the diode because you just touch, but with the CO2 is even more because you don't touch it. So with the floating foot plate, also with revision stapedotomy, the CO2 is more indicated, let's say. But the key point is that the TRIO is the only platform in the market that gives to the ear surgeon the possibility of doing the intervention of stapedotomy in the less traumatic way, most effective way, fastest way, and also sure and repeatable way.
I really appreciate your time. It's been great meeting you in person now and seeing all the incredible work that you and your team has done. Like I said, down from the screws as they come into the warehouse up to testing the laser at the very end. You've talked quite a bit about the system itself, but also about some important concepts in devices, the ergonomics, the patient care, implications for broader society. As we wrap up, do you have any other really key messages that you'd like to talk about, either about CO2 lasers or trends in healthcare?
Well, a message that I would want to give, let's say, to surgeons in general, it's not to be scared about the laser, and in particular about CO2 laser, because in the end, it's more your friends that's something to be scared of, and yeah, this kind of technology can just improve the way that they can do their surgery. We are working on it to improve it more and more.